Good day. Today we're going to talk about factoring quadratics. And I want you to think of factoring quadratics basically as reverse distributive property. So when you have two binomials and you do distributive property, or you might call it FOIL, then you end up with either the difference of two squares. You could end up with a trinomial that has both a plus and a plus, or a plus and a minus, or a minus and a plus. Basically, what we're going to do is undo that. So these are the things I need you to think about. Question 1. In the problem, is there a greatest common factor? If so, make sure you factor it out first. Question 2. What is the product, or think of it as the answer, of the first term, called A, multiplied by the third term, called C? Now when you do this, you have to make sure that everything's written in order. So it would be ax squared, so the a is the number, plus bx plus c. So you have to make sure that it's written in this order for this to work. So you would take the number that's considered the a term and the number that's considered the c term and multiply them together. Then you would find the factors, or the two numbers multiplied together, that add to the middle term called b. So a times c needs to add to b. Using those two terms, the two that were the factors, rewrite the middle term. So basically we just split the middle term into the original two terms that were there before we added them together. Next, you would group the first two terms together and the last two terms together and take out the GCF from both. And finally, of course, rewrite the original expression as two binomials. Don't forget to check your work. So we're going to start out here with number 1, and we've got m squared plus 9m plus 20. So is there a GCF? No. And we know that there's an imaginary 1 in front of this m squared. So I'm thinking to myself, what are the factors of 1 times 20 that add to 9? So what are the factors of 20 that add or sum to 9? Let me put a 2 in there. So think of the factors of 20. We have 1 and 20, but that equals 21. And these are this is a positive number, so I'm only going to use positive factors. 2 and 10, but that would give us 12. Not 3, because 3 doesn't go into 20 evenly. How about 4 and 5? When we add 4 and 5 together, we do get 9. So we're going to use the factors 4 and 5. So what we do is we write the first term, and then we split the 9m into these two terms. And they both need to have an m on them, because remember, we started combining like terms, and if I don't put the m's on there, then I can't combine them to make this number. So we're going to do plus 4m plus 5m, and it's plus and plus because both of these numbers are positive, plus 20. My next step is to group the first two terms and then group the last two terms. And I'm going to take out a common factor here. My common factor is m, because m appears in both terms. When I do that, what happens is I would say m divided into m squared. Well, we know that m squared comes from m times m. And if I take one m out, all I have left is an m. And then 4m divided by m just leaves us 4. And then here in the second set of parentheses, or the second binomial, I know that 5 is a factor of 20. So I'm going to take out 5. And that leaves me 5m divided by 5 is m. 20 divided by 5 is 4. Now it's very important that whatever you do, you make sure that the middle two terms, that's a wrong way to say that. Make sure that the binomials in the parentheses are exactly the same. If they're not exactly the same, you've done something wrong. So the first thing I'm going to do is write m plus 4. Even though you see it twice, it only counts as one factor. Then I've got m plus 5. And it's plus 5 because 5 is a positive number. So the numbers and the letters that I have circled, that's going to be the other factor. So now I've got m plus 4 multiplied by m plus 5. Now, if I have done this correctly, when I distribute, then I should get this answer. M times m is m squared. M times 5 is 5m. 4 times m is 4m. And 4 times 5 is 20. Combine like terms, and I have m squared plus 9m plus 20. So I do believe my answer is right. So I'm just going to put my answer in here. All right, let's do the next one. All right, the next one is 5f squared plus 40f plus 75. First question, is there a greatest common factor? Hopefully you said yes, because 5 goes into 40 and 5 goes into 75. So we're going to say, okay, pull out our greatest common factor of 5. That leaves us with f squared plus 8f plus 15. Now, how did I get that? I just divided 5 into every one of these terms and wrote down what was left over. So now I'm thinking of what are the factors of 15, because 1 times 15 gives me 15. What are the factors of 15 that add to 8? And again, both of these are positive, so I know my factors also need to be positive. Well, 1 times 15, but that adds to 16. 2, no. 3 times 5 is 15, and 3 plus 5 adds to 8. So here is the two factors I'm going to use. So I keep my 5 out here, and I'm going to kind of just put a little space. And then over here, I'm going to do f squared. And remember, I'm splitting the 8f. So that's plus 3f plus 5f plus 15. Now I want to talk about the order which I chose. When you're choosing the order which to write your factors in to split, try to make it so that you don't end up with a fraction. In other words, your coefficient should be a factor of the other number. I know 5 goes into 15, so that's pretty good. I could have used 3 over there as well. Either way would have worked. So now group your two binomials. Here I have f in common, and what's left is f plus 3. Here I can factor out a 5. 5f divided by 5 is just f. 5 divided into positive 15 is positive 3. Notice these are exactly the same. So I've got f plus 3 as one factor or binomial, and then f plus 5 as the other. Now you might be tempted to think that you're done. However, by looking at this, if I do f times f, that's f squared, but this says 5f squared. So I have to rewrite this so that the 5 is outside of both binomials. And then we're going to check it. So we've got f times f is f squared plus f times 5 is 5f plus 3 times f is 3f plus 3 times 5 is 15. And outside of that, we'll put my 5. Let's try to squeeze this up here. Then I've got f squared plus 8f plus 15. Multiply that by 5. That gives me 5f squared plus 40f plus 75. And that indeed is what we started with, so that's correct. right, let's go on with the next one. All right, next we've got 4y squared plus 40y plus 84. Our first question, is there a greatest common factor? Well, I know that 4 goes into 4 and 4 goes into 40, but you might want to check and see if 4 goes into 84, and I believe that it does because it ends in a 4. So we're going to factor out a 4, and we're left with y squared plus 10y plus 21. So then my question becomes, what are the factors of 1 times 21, which is 21, that add to 10? And again, this is all positive. So I'm looking for, well, 1 times 21 gives me 21, but adds to 22. And then we have 3 times 7. Multiplies to 21, but adds to 10. So these two are my factors. So I'm going to bring down my 4, and this time I'm going to write y squared. I'm going to do plus 3y plus 7y plus 21. So I just split this 10y into these two factors. Now we're going to group these together, and I'm left with, of course, my 4. Then I bring out y, because y is common to both terms, and I'm left with y plus 3. Then here, 7 is common to both terms, and when I factor that out, I'm left with y plus 3. So my first set of factors is, I'm going to skip a line because it's getting kind of messy to me, y plus 3. My other factors are y plus 7. And then, of course, I have my greatest common factor that I took out originally. Let's go ahead and check it. Y times y is y squared. Y times 7 is 7y. 3 times y is 3y. 3 times 7 is 21. And we still have our 4 out here. Let's go ahead and combine these like terms. We're left with 4 times y squared plus 10y plus 21. 4 times y squared is 4y squared. 4 times 10y is 40y. 4 times 21 is 84. Is that what we started out with? It is. So we know we're right. All right, here's our next one. It's going to be pretty straightforward because the coefficient is 1. So we don't have to do a greatest common factor. This is supposed to be a J. So I'm thinking, what are the factors of -9 that add to +8? So we know that if this number is positive, then our highest number when we add has to be positive. And one of the numbers has to be negative, because a negative times a positive gave me this negative. So I'm thinking, okay, well, how about 1 and -9? I don't think that'll work, because 1 plus -9 is -8. So now let's just switch the sign. So we're going to do -1 and +9. Well, 9 minus 1 is +8, so we're going to use this factor here. So we've got y squared, split this term to -1. Oh, I'm saying y, it's j. Can't even read my own writing. -1j plus 9j minus 9. Group your first set of terms, group your second set of terms. Well, we can pull out a j because it's common to both, and we're left with j minus 1. Here, we can pull out a 9, and we're left with j minus 1. So, again, j minus 1 becomes one binomial, or one factor. The other factor is j plus 9. And we're done. So, all right, there we go. Let's go ahead and do the next one. U squared minus 6u minus 7. Do we have any greatest common factors? No, we don't. So we're thinking, what are the factors of negative 7, meaning 1 times negative 7, that add to negative 6? Well, both of these are negative, so one factor has to be negative and one has to be positive, and the larger one's going to be negative because this middle term is negative, and the factors of 7 would be negative 7 and positive 1. That gives me negative 6. So we do u squared minus, I'm going to do the plus 1 over here, it'll just be easier, plus 1 u minus 7u minus 7. Again, group your terms together. Well, I can take a u out here. That would leave me with u plus 1. Now here, notice I have a negative 7. So I'm going to factor out a negative 7. And when I do that, it's going to change this sign here in the middle to a positive. So negative 7 divided into negative 7u is positive u. Negative 7 divided into negative 7 is positive 1. So here we have one set of terms, or one binomial. The other binomial is what's outside, so that gives me u minus 7. Now, I didn't check this one. Let's check this one. So we have u times u, which is u squared, u times negative 7, which is negative 7u, 1 times u, which is positive 1u, 1 times negative 7, which is negative 7. Combine your like terms, u squared minus 6u minus 7. That's exactly what we started with, so we're correct. Now what I'm going to do is I'm going to go ahead and jump a couple of levels to get us to the higher ones so you can see what those look like. All right, what I noticed is everything up to this point was either you were using a greatest common factor and then doing what we were doing before. Now, if you notice on this problem, which is 4s squared minus s minus 5, there is no greatest common factor, so there's nothing to pull out. However, we still want to use the method where we multiply the first term and the third term. So a times c. So 4 times negative 5. We're looking for the factors of negative 20 that add to negative 1, because there's a negative 1 imaginary in front of this number. So we know that if this is negative, our largest factor has to be negative. So negative 20 plus 1 gives us negative 19. That won't work. Negative 5 plus positive 4, that gives us negative 1. That does work. So we say 4s squared, and I'm using these factors here, and I'm going to use the 4 because that'll factor out easier. So plus 4s minus 5s minus 5. So again, group your factors. Look here, you have 4s in common. That leaves you with s plus 1. Here we're going to factor out a negative 5, and that leaves me with s plus 1. So my first factor is s plus 1. My second factor or binomial is 4s minus 5. Let's check it. S times 4s is 4s squared. S times negative 5 is negative 5s. 1 times 4s is positive 4s. 1 times negative 5 is negative 5. Combine like terms, so I have 4s minus s minus 5. And that's exactly what we started out with, so that's correct. All right, let's see if we're right. And we are. So I want you to go ahead and continue. Try to make 100. I'll talk to you.